Most material about semiconductors starts with a review of the physics of doped semiconductors, but that is not the focus of these videos. We are going to focus on how to analyze circuits with these devices, starting with the PN junction diode. I'm assuming you've completed an introductory circuit analysis course using the three common passive elements. Those are resistors, capacitors, and inductors, and that you've learned how to perform nodal analysis. So let's focus on the difference between resistors and PN junction diodes. Pay close attention to the polarity of the voltage and direction of the current in this image. While a diode is not a passive circuit element, we will label the voltage and current in a manner consistent with the passive sign convention. In this image, the anode of the diode is on the left and is labeled with the positive side of the voltage, and the cathode of the diode is on the right and is labeled with the negative side of the voltage. The current flows from positive to negative, which in this image is from left to right. Voltage across and current through a resistor are related by Ohm's law. To plot that with the voltage as the independent variable and current as the dependent variable, we need to rearrange Ohm's law, solving it for current. Adding that to the plot, we see a nicely behaved linear relationship for a resistor. Now, when we consider a diode, things are more complicated. To write the relationship between voltage across and current through a PN junction diode, we have to express it as a piecewise function with three distinct regions of the domain. The first region covers positive voltages greater than some forward voltage we call V sub f. In this region, the current increases exponentially as voltage is increased. The second region covers voltages below V sub f and greater than a voltage we call the breakdown voltage, or V sub Br. You can find this value in a datasheet for the diode. In this region, the current is a very small negative value called the saturation current. It is usually small enough that we can assume that it is zero. You can also find this value in a datasheet for the diode. The third region covers negative voltages less than the breakdown voltage. Most of the time, the diode will not operate in this region. However, there are some diodes and some circuits that are specifically designed to operate in this region. We will cover those cases in future videos. These regions are added to the piecewise definition of the volt-amp relationship for a diode, and can be graphically added to the plot. These regions, from left to right, are called the breakdown, reverse, and forward regions. How are we going to analyze circuits with diodes? Let's recall what laws formed the basis for nodal analysis. Nodal analysis with resistive elements requires Kirchhoff's voltage law, Kirchhoff's current law, and Ohm's law. But Ohm's law only relates voltage and current for a resistor. When we consider diodes, we have to replace Ohm's law with the piecewise function that relates voltage and current for a diode. In the next videos, we will explore how to analyze circuits with diodes given this more complicated volt-amp relationship. So stay tuned and good luck.